I wonder if they ate a lot of almonds back in the day of Julius Caesar. Well, they ate a lot of olives, probably grapes. But I like almonds a lot. If they did, I probably would have liked living there. That's totally beside the point, irrelevant. But again, to divide out or not to divide out this fraction, or this variable, that's the question. Hopefully, if you've watched my Julius Caesar renditions or editions of my videos at this point, you've discovered that the answer would be to not reduce those variables, because you can't. What you need to do instead is factor first, okay? Numerator. The degree on my numerator is going to be over here on my second term, right? So I usually like to have the term with the degree on it. Basically, that's going to be my leading coefficient. I want that guy to be positive, usually. That's just, it works better for me, historically, in my experience, so that's how I'm going to run with this. So to do that, I'm going to factor out a -1 in the numerator. What that does is it's going to change all the signs in the numerator. You know what? I'm going to do more than that. I'm going to factor out a -3. That'll give me -1 plus x squared. Okay. I'll leave the denominator as it is for right now. Just looking at this numerator a little bit more. Some people get a little hung up when they factor out a negative number like that. And usually I say, to see what's really going on, multiply it back through and see if you get this back. And usually when you do that, it clicks. You're like, oh yeah, I get it now. Right? -3 times a -1 is that +3. -3 times a positive x squared is this -3x squared. Okay, so that's how you factor this appropriately. Now I'm going to use a commutative property of addition and make these two guys switch around. So I'll have a -3 times a quantity of x squared minus 1, still over x squared plus x minus 2. All right? Now, in the numerator, I've got the difference of squares. In the denominator, I've got a trinomial that'll factor pretty easy. And I'm not going to go into the elaborate x thing that you may have seen me do in other videos. I'm going to go straight to what these factors are going to be. Numerator is going to be x plus 1 and x minus 1. And the denominator is going to be x plus 2 and x minus 1. Okay? Hopefully you're able to see how that denominator factors. The 2 times a -1 is a -2. And if you multiply the x times the -1, which is -x, -1x, and the 2x, that's a positive 2x, -1x plus 2x is this positive 1x that you see here. So I've got this factored properly. So let's see what common factors we have. In the numerator, I've got the x minus 1, and in the denominator, I have an x minus 1. And these factors get multiplied to everything in the denominator and everything in the numerator, which makes these guys eligible for dividing out. So to divide out or not to divide out these factors, that is not a question. That's a flat-out statement. Yeah, that thing's gone. It's gone. My answer here is going to be a -3 times a quantity of x plus 1 over x plus 2. And that guy's done. You can distribute that -3 through if you want, but typically they just leave it factored out in its factored state for purposes that if you take math, college algebra or calculus and those, it's actually a lot easier to work with these when you're graphing and things like that. You got to find these different kinds of asymptotes and everything. So, but I'm going to leave that for some other course actually.